Hello everyone, and welcome back to MIS 5000 Special Topics in MIS. Today we're going to be introducing the concept of counter-controlled loops. In the last module, we discussed sentinel-controlled loops, or indefinite loops, for which we do not know initially how many times they are going to run. One of the primary differences here for counter-controlled loops is that we know beforehand how many times we would like to repeat a specific action or specific actions. The learning objectives for this module are as follows. After this module, you should be able to define the concept of a counter or index variable and explain its role in a counter-controlled loop, create a flowchart that models the logic of a counter-controlled loop, identify the most common counter-controlled loop mistakes, and identify the most common applications of counter-controlled loops. So how do we model definite loops with counters or counter-controlled loops using flowcharts? We're going to walk through 3 separate examples. Let's take a look at this first example. It's extremely simple. We're going to create a flowchart for an application that counts from 1 to 10. So we're going to create a flowchart for an application that simply prints the numbers 1 through 10 to the console. Let's go ahead and head over to Microsoft Visio. As always, I'm first going to pull out 2 squares for my description and my legend. Our description is fairly straightforward. This application counts from 1 to 10 on the console, and I'll go ahead and prepare our legend. Next, I'm going to, of course, drag out 2 ovals for our start and stop terminals. So all we want to do is simply output 1 through 10 in order. So we don't actually need any user input here. So I'm going to walk you through the process of flowcharting a counter-controlled loop. What you'll notice is that this overall structure is quite similar to that of a sentinel-controlled loop. We are going to use a decision to test whether or not we're going to keep repeating a set of actions. The difference here is that for our decision, we are going to check to see whether or not our index or our counter variable, in other words, the variable that will represent which iteration of the loop we're on, is still less than or equal to the maximum number of times that we intend to repeat the set of actions. There are 3 main parts of a counter-controlled loop. The first is that of setting up or initializing our index or counter variable. So before I do that, I'm going to add a variable to the legend. I'm going to call it, in this case, counter. What you'll see later is that I'll either call it I or index, just depending upon the situation. But here the counter is going to be an index variable that keeps track of which iteration of the loop we are currently on. Now, in case you haven't seen this keyword iteration before, iteration refers to which time of running of the loop that we are on. So if I'm counting and I'm printing out the number 2, we are on the second iteration. In the case where we're working with Python, we're going to start at 1, move from 1 to 2. So if the counter is 2, we are on the second iteration of the loop. The same concept applies to the sentinel-controlled loop, but we very often do not keep track of a counter when we are using that kind of loop. So the first thing we need to do in the counter-controlled loop is initialize our counter variable. So I'm going to bring out a rectangle to do this. This is going to be a process in which I simply set the counter to 1. Now, what you set the counter to is going to depend on a lot of factors. One factor will be the actual programming language that you're using. The other factor will just depend upon the situation. Perhaps you want to set the counter to 100 and count backwards. Maybe you want to set your counter to 5 and count forwards. Maybe you want to start your counter as a negative number. It all kind of depends. In this case, I'm going to simply start the counter at 1, which again, the 1 will represent the first iteration of our counter-controlled loop. What I'm also going to do is introduce a second variable called max. The max is going to represent the maximum number of times the loop will run. So we, again, can use a constant variable for this if we want, so that we could change it so that perhaps the loop could be dynamic. Say we want to print 1 to 20. We could set that up that way. In this case, I'm just going to hard code the max right underneath the counter variable. So I'm just going to set max to 10 to start. So there is still a decision that gets made during the counter-controlled loop. And that is, has the counter variable reached a value, in this case, that is greater than the maximum number of times that I want the loop to run? So to represent this, I'm going to bring out the diamond, and I'm going to write the decision like this. So is counter less than or equal to max? Now I could set it up the opposite way. I could check to see if counter is greater than max and have my true and false branches flipped. I'm going to choose to set it up this way. So basically what's going to happen is while we're counting, the first run we're going to print out the counter, and it's going to be 1. We're then going to increase the value of the counter by 1, so it becomes 2. We come back to the decision and check, okay, is 2 less than or equal to 10? It's true, so we'll do it again. We'll increase the counter to 3 and perform the check again. So you can see why it's important to initialize the counter to 1 to start, because if we don't have a value for counter when we start, when I come to this check, I will get an error. Similarly, we do not want to initialize the counter inside the loop, because then we'll end up with an infinite loop, as 1 will always be less than 10. So again, 3 steps. We need to initialize the counter. That's our first step. Our second step, we have to perform the check, is the counter less than or equal to the max? The third step is going to be that of increasing the counter, or incrementing, I'll use that word, which just means we're going to increase the value of the counter variable by 1 inside the loop, so that when the check is performed again, eventually counter will be equal to 11. 11 is not less than or equal to 10, and the loop will terminate. So let's go ahead and put our true and false branches out on this decision and go from there. So at the end of the application, in other words, when it's done, when counter becomes 11, all we're going to do is terminate the program. So we can actually already add our stop terminal to the false branch. On the true side, we need to do a couple of things. First of all, since we're printing the numbers 1 through 10 to the console, the first thing we're going to want to do is, since the counter starts at 1, we're going to want to first print that output of counter. So I'm going to pull a parallelogram to do this. Say just simply output counter. And I really do have to be careful about the order that I'm doing things in, and just be mindful of what I'm trying to do, what the decision actually is. So, whether or not it's strictly less than or equal to, where my counter starts. I have to see how all these working parts work together in order to make sure I'm actually getting the output that I want. So my point being that if I chose to increase the counter by 1 first, then I'd actually print 2 first instead of 1, and that's not what I want. Or I could, adjust the output so that it were counter minus 1. There are a lot of different ways to accomplish the same task. In this case, to avoid having to add or subtract, I'm just going to first print the counter to the console. Then I'm going to take care of the next important part of the counter-controlled loop, and that is incrementing the counter on each iteration. So what I'm going to do is similar to our previous example of increasing a value by 1, I'm going to do counter plus plus. So this will set in the first iteration. Counter is 1, I add 1 to it, so now counter becomes 2. I'm now ready to complete the loop, so I'm going to add a connector before the decision point in order to accomplish this. I'm going to then pull from this process up to that connector, and now let's go ahead and do our testing here. So I start at the start terminal, I set the counter to 1, and my max to 10. So counter is 1 and max is 10. I come to the decision, is 1 less than or equal to 10? That's true. So I output 1, and then I increase the counter by 1. So now the counter is 2. I then repeat. I check, okay, is 2 less than or equal to max, which is 10? This is true again. So I do the same thing. Now I print 2, I increase it to 3, and so on. Once I get to, so let's skip to where the counter is actually equal to 10. So I check, is 10 less than or equal to 10? That is still true, actually. So I print 10, I then increase the counter to 11, and come around again. Now, however, when I check, is 11 less than or equal to 10? That is not true. So I will not actually print 11, even though I increased counter to 11. So at that point, it will terminate. So you can see that the process is quite similar. It's just controlled by that counter variable. The counter variable in this case is our loop control variable. So again, in practice, it may vary. What you need to be aware of is just what decision are you checking? What did you set your counter to? How are you incrementing your counter? Because you can also increment it by values of 2 and so on. It really, again, it depends on the situation. But this is a very basic loop that runs from 1 to 10 and runs exactly 10 times. I'll go ahead and upload this to Blackboard as counting. Let's take a look at another application. This application is slightly more complicated. So we're going to create a flowchart for the following application. It asks how many times a 6-sided die should be rolled. The die should be rolled that many times, and each time it is rolled, the number on the face of the die should be returned as output. When the application is finished running, it should report how many times the number 4 was rolled. So you can see that this is very similar to the other dice problem. The main difference here is that we are asking beforehand how many times the die should be rolled. And based on that, we're going to check to see if we rolled any 4s, count the number of 4s we rolled, and then output that at the end. So we are still actually taking a running total, but in this case, it's happening inside a counter-controlled loop. Let's go ahead and head over to Visio. Again, I'm going to drag out my squares for my description and my legend and set those up. So this application asks the user how many times they want to roll a 6-sided die and then rolls the dice that many times. Each time it is rolled, the number on the face of the die is returned as output. After the die is rolled the max number of times, the number of times 4 was rolled is reported. So what I'm actually going to do this time is I'm going to copy over the diagram that we just created, because I do want to show you how things can be reused. So here we have our original counter-controlled, very basic loop. The same rules apply, but we need to modify it a little bit to take care of the user input and the counting of the 4s. So let me disconnect a few things so we can get this going. The first thing we're going to need to do this time is actually ask the user how many times they want to roll the dice. So we'll have our prompt, how many rolls, and I will have a variable that stores the number of rolls. So notice this time that instead of the max, we're going to use the variable rolls to keep track of our max. Go ahead and add that to our legend. So the rolls is the user chosen number of total dice rolls. So I'm going to go ahead and get rid of the max variable here. Next, I do again need to initialize our loop control variable or our counter variable. So the counter variable specifically that's going to control the loop, not the variable that's going to keep track of the number of 4s. So we ask, okay, how many times do you want to roll the dice? The next thing we're going to do is initialize our loop control variable, which in this case is going to be the counter. We are also going to initialize a few other variables. So we're going to have a variable that stores the face of the die when it's rolled. I'm just going to set that to 0 beforehand. And then we're also going to want to count the 4s. So we need, similar to the other dice example, a variable 4s that we set before the loop starts to 0. So it's interesting, we have 2 counters here. One of the counters, the counter variable, controls the loop, and the 4s variable is going to represent and get incremented only when we roll a 4. So let's go ahead and keep going. We're going to have to make some additional modifications here. So we first have to change our check. In this case, we're checking, okay, is the counter, which starts at 1, less than or equal to, in this case, it's the total number of rolls. So is the counter less than or equal to the total number of rolls? Let's take care of the false branch first because it's the simpler branch. When the die is rolled the max number of times, then the number of times the number 4 was rolled is reported. So we're going to grab a parallelogram here that will give us our output. So output 4 was rolled 4's times, which of course we haven't actually incremented it at all, but we now have the output after the termination of the loop. Now in the last case, we had to output the counter first because we were printing from 1 to 10 and we only wanted to use the simple variable of counter. This is a little bit different. Because we're not sharing the counter variable to the console, we can go ahead and increment it first so that we don't forget. So let me go ahead and make a couple of adjustments here and then talk about them. So the first thing we're going to do is increment the counter by 1. So again, the counter controlled loop control variable. We're also going to, just like we rolled the dice last time, set the face to a random number between 1 and 6. We now have a valid value for face. Then after we roll the dice, we want to share that value with the user. So we're going to have another parallelogram for output. So we have output roll plus face. Now we need to add the logic to check to see whether or not we rolled a 4 and increase the 4's variable accordingly if we did in fact roll a 4. So we're actually going to have another decision underneath here that checks to see, okay, is face equal to 4? Let's go ahead and connect that. Okay, so every decision has a true and a false branch. Same thing applies here. So I'm going to go ahead and start my 2 branches, true and false. So if the face is not equal to 4, well, then we don't have to take any action. If the face is equal to 4, we need to increment this 4's variable. So we'll go ahead and do that in a process. I'll go ahead and use a rectangle for that process. It will simply read 4's plus plus to represent adding 1 to the variable 4's. I then need to join these 2 branches back together using a connector. So we'll grab another circle for that, join the false branch on this side, join the true branch on this side, and then after we complete this check, we can actually circle back around to our check on the counter loop control variable. So let's go ahead and do a practice example here. Let's do some testing. So how many rolls? Let's say we input, quite simply, 2. So we're going to roll the dice 2 times. We set, so rolls becomes 2, counter is 1, face is 0, and 4 is 0. So we check, is 1 less than or equal to 2? That is true. So we increase the counter to 2. We roll the dice. Let's say we get a 4. We output that 4. We check, okay, is face equal to 4? It is. So we increase 4's by 1. So now 4's is equal to 1. We come back around. The counter is at 2. Is 2 less than or equal to 2? It is. So we then increase the counter to 3. We roll again. Let's say we get a 6. We output that 6. We check, is 6 equal to 4? It is not, so we take no action. We cycle back around. Now we check, is 3 less than or equal to 2? It is not. We take the false branch and we have the output 4 was rolled 1 time, which I guess I can edit this for the case where we only rolled 1 time. So I'll go ahead and put this on Blackboard. Again, the same 3 components are here. We initialize the loop control variable, the counter. We make the correct check. So is counter less than or equal to rolls? And then we increment that counter. We had some additional logic here dealing with whether or not we rolled a 4, and we set that up accordingly. Let's take a look at one final example. This example is going to have you start to think about using a specific type of data structure. Again, keeping it as language independent as possible. So we're going to create a flowchart for the following application. It will ask the user for their name and then spell it out letter by letter. So this is going to show you one of the most common applications of a definite or counter-controlled loop. If you think about this application, the way it would work is, so we ask the user for their name, let's say, for example, that it's Bob. We then need to spell it out letter by letter. So if we were to do that in the air, it would be, okay, we check the first letter, that's B, then O, and then B. So we've taken the action of saying a letter in the name each time, and we've actually said a letter 3 times. And it just so happens that 3 is equal to the length of characters in that name. So if we were to spell out my first name, it would be 9 times that we would cycle through, Katherine. So what we're going to do is think about the loop control variable increasing until we've reached the end of the word. So let's take a look at what this would look like in Visio. So I'm again going to have my description. So this application asks the user for their name and then spells it out letter by letter. When the spelling is done, it says goodbye to the user by name. And we can add our legend. In this case, I'm already going to put in our counter. So we're always going to have some kind of counter index in our counter-controlled loop. So we have our counter index variable for the name loop, because we're going to loop through letter by letter. And then we also have a variable that will hold the user's name as their input. So I'm actually going to again copy over our basic counter-controlled loop structure to again show you how you can reuse that logical structure. Let me go ahead and make a few adjustments so we can get started. So the first thing we need to do is ask the user for their name and store the result. So I'm going to grab a parallelogram for that. So we'll just simply prompt them with name and collect the name in the name variable. The next thing we need to do, as always, is initialize our loop control variable. So this is going to be the counter. Again, we need to set it to 1. Okay, now we're actually ready to start our loop. So I'm going to go ahead and reconnect this connector point. Now our check's going to be a little bit different in this case. So up to this point, we've been given a value for the maximum number of times that we want the loop to run. Here, it's a little bit more implicit. We need to sort of tease it out. And so I'm going to give you a Python function to get the maximum number of times for the loop. So we want to run the loop as many times as there are letters in the user's name. So since we're using the length of the person's name as the maximum, what we're going to do is check to see if the counter is less than or equal to the length of that name. So in the case of the name being Bob, the length of Bob will be 3. So we're going to check, okay, is 1 less than or equal to 3, and so on until we are greater than 3. The next thing we're going to do is output the first letter in the name to the console. So that's going to look like this. We're going to use square brackets to capture the character at each location in the string. This will introduce you a little bit to the concept of lists in Python. So here's what that's going to look like. So for example, name at 0 would be the capital B for Bob. Name at 1 is going to be the O, and name at 2 is going to be the lowercase b. Now it's a little bit tricky because when you're dealing with this kind of list, the index actually starts at 0. So name at 0, if it is Bob, is going to represent the first letter. So because of this, we need to, instead of using name at counter, because counter starts at 1, we need to output the letter at name at counter -1. So let's walk through this so you can better understand what's going on here. So we start the application, they've input Bob, we set our counter to 1, we then check is 1 less than or equal to the length of Bob, which is 3. It's true. So then we output the character located at 1 - 1, which is 0. So the position of 0 in Bob. Position of 0 in Bob equates to the capital B. So we do that. And then just as always, we then increment the counter. I suppose to simplify this, we could actually flip these two. But I'm going to keep it this way for now, just so that you realize that when you're dealing with this kind of list, that it starts at 0. But again, to simplify this, you could actually flip these two items and get rid of the -1. So I think this actually takes care of everything. So let's run through the entire example where the user inputs Bob. So we ask them for their name. They say Bob, so name is now equal to BOB. We set our counter to 1. We then check is 1 less than or equal to the length of Bob, which is 3. It is. So we output the letter that comes at position 1 - 1, which is 0 in Bob. So that's the letter B. We then increase the counter to 2 and repeat, is 2 less than or equal to 3? That's still true. We then output the character at position 2 - 1, which is 1. So the second letter in the name, which is going to be the lowercase o. We increase the counter again to 3. Run again. Is 3 less than or equal to the length of Bob, which is 3? That's true. We then output name at 2, increase the counter one more time to be 4. We run the check again, and we see that 4 is not less than or equal to 3, so we terminate, exit the loop. The last thing we're going to do is add a little message to the user that simply says goodbye and calls them by name. So we can add this output to do that, and then finally terminate the application. I'm going to add a couple of notes on the side to clear up a couple of things about this length function, as well as how this list works on the flowchart before uploading it to Blackboard. Okay, so now that we've taken a look at several examples of counter-controlled or definite loops, let's answer a couple more questions. So what is a counter and what role does it play in a definite loop? So let's answer this by taking a look at the 3 required components in a definite loop one more time. So the counter is what's going to be the loop control variable. So we have to first make sure that we initialize the counter, so by setting it to whatever number we want it to start at. We then use that counter to check to see whether or not it's reached the max that we want to actually run the loop. Again, this could depend on the situation. It doesn't always have to be 1 to 10. It could run backwards along the number line. It could start at a value less than or greater than 1 as well. We also then need to make sure we increment the counter each time we run the loop or iterate to make sure that we don't end up with an infinite loop. If we omit this step, we're going to just keep running the loop forever because the counter will always be less than or equal to the max. So what are the most common mistakes that you can make when using a definite or counter-controlled loop? Similar to the sentinel-controlled loop, the mistakes have to do with each of the required components. So if you fail to initialize the counter, we won't be able to actually do the check initially to see if it's reached the max. You can fail to check the correct condition, so maybe you set the max incorrectly, or you're not checking to see if it's less than or equal to the correct variable. And then finally, this is kind of the biggest one and most common mistake, is that you fail to increment the counter each iteration. So failing to do so will result in an infinite loop. And the reason, again, that we talk about these loops in terms of sentinel-controlled and counter-controlled, instead of if you've had coding experience for and while, is that a while loop can actually be used as a sentinel or a counter-controlled loop. So the idea of while and for, while they are different and operate differently, those really aren't how we want to conceptualize 2 different kinds of loops when it comes to logic. We want to determine whether or not the loop control variable is a sentinel or whether or not it is a counter. And while it is more common to use a for loop for counter-controlled repetition, you can use a while loop as well. So finally, what are the most common applications of definite loops? There are many applications, but the most common is that of iterating through lists of items. So we saw this in the case of working through each letter in the name. If we are counting items, if we're taking total of a set of items that we have in a list, that the counter-controlled loop is how we're going to accomplish that. If you have any questions about the examples or about counter-controlled loops in general, please let me know.